All right, let's keep working on 5.3. This is part 2. All right, so this problem is a little different only because they are giving you the mean and the standard deviation. Everything else works the same. So when we draw our curve, it's going to work. Whoop, there we go. It's going to work the same way. It did not tell. Oh, yes, it did tell us. Okay, so let's take a look. It says the mean is 50, right? The scores for a California Peace Officer Standards and Training Test are normally distributed. So that means we can use the normal calculator with a mean of 50 and a standard deviation of 10. So that's great. We need that because we're going to put the 50 in here into the normal calculator and the standard deviation of 10 into here. Okay, then it says an agency will only hire applicants with scores in the top 10%. So if we go up here to the right-hand corner, the top 10%, come on, is only going to be the few people up here. And so we have to make sure that our inequality points in that direction. So sure enough, down here in the StatCrunch, we're going to make sure that we have a greater than or equal to. All right, then we know that 10% is going to be the area in here. And so that's going to be 0.10. And that's going to go on the right side here of my boxes. And then when you hit compute, it's going to give you the score. And so in this case, the score that it gives me is 62.8. That's right here. So that's the box that you're going to be given once you give the other data. What's really nice too is it shows the graph in the normal curve. And so you can see that the area is over here, right where it should be, because it said the word top. So top 10% means that the scores have to be high and be on this right-hand side. Okay, so this is just an explanation from the book. You're welcome to look at that. Let's keep going. But we're going to use StatCrunch. Okay, so let's read this problem. In a randomly selected sample of women ages 20 to 34. So that just tells us that all of the people, all of the data in this study is from women who are in the age group 20 to 34. We do not need that for what we're doing in StatCrunch. That's just informational. So then it says the mean total cholesterol level is 179 milligrams per deciliter. So we're going to grab that the mean is 179 with a standard deviation of 38.9 milligrams per deciliter. So that means that our standard deviation is 38.9. It says assume the total cholesterol levels are normally distributed. We're glad to see that because that means we can use the normal calculator. It also means we can draw our bell-shaped curve. Then it says find the highest total cholesterol level a woman in this 20 to 34 age group can have and still be in the bottom 1%. So bottom 1% means that we need to be over here on the left, right? And we're going to change our 1% to a decimal of 0.01. All right, so we're pretty good. We know our mean, we know our standard deviation, we know that we want to head to the left because it said the word bottom 1%, and we know that that area is going to be 0.01. Be very careful when you're switching these percents to decimals. So now we're going to go into StatCrunch. We are going to hit Stat Calculator Normal. Now this time, the StatCrunch automatically comes up with a mean of 0 and a standard deviation of 1, but we have a mean and a standard deviation that we need to put in. So we're going to put the 179 in here. That's because that's what the problem gave us for mean. We're going to put the 38.9 in for standard deviation. That's what the problem gave us for standard deviation. We know we're headed to the left, right? We're headed because we want the bottom 1%. So our inequality needs to be less than or equal to, so we're pointing to the left. We are not going to enter the next box. That's going to be computed for us. We're going to enter on the right-hand side the area, and our area is 0.01. At that point, when you hit compute, it's going to give you the cholesterol level of a woman who is sitting there. So we're looking at the number line, and that is the very top of the bottom 1%. And so for this one, it's going to be 88.5. We're going to be doing more practicing in our other sessions where we draw the number lines and take a look at these. This is how you would do the problem without StatCrunch. Again, why do that when we have StatCrunch? But you're welcome to do that if you want to. This is what will happen if you hit Help Me Solve This. So Help Me Solve This is going to make you do everything by hand or using tables. If you reach out to us, we'll help you with StatCrunch. Okay, this problem gave us the graph. And so it gave us this graph right here, showed us the area for each side. So on each side of the mean, we want 47.5%. It's looking for the z-scores. It's looking for the number line. So I went ahead and added those together. You could do them separately, but why do that? So I added the 0.4750 from the left to the 0.4750 on the right, and that gave me 0.95. That's what I'm going to use for my area. But now I have to use between, right? And so we're going to click on the between here in the normal calculator in StatCrunch. They didn't give me any mean or standard deviation, so I'm going to leave that at the mean at 0 and the standard deviation at 1. I'm looking for the z-scores, so I'm not going to put anything in these boxes on the left. I'm going to put my area that I found up above, the 0.95. I'm going to pop that into the right-hand side and hit compute. When I do that, it's going to give me the two z-scores. So on this side, on the left side, it is negative 1.96. On the right side, it is positive 1.96. We know this is symmetric. And so we know that those are going to be the same number. It's just on the on the left-hand side, it's going to be negative because it's below the mean. On the right-hand side, it's going to be positive. Okay, let's take a look at new problem. Find the z-score that has 61.4% of the distribution's area to its right. So let's draw our own little curve over here. My curves are getting worse instead of better. Okay, so I know a couple of things. I don't have a mean or a standard deviation, so I'm going to deal with a mean of 0 in the middle, standard deviation of 1. I want 61.4% of the distribution's area to be to the right. So I have quite a bit of area here, past the 50% mark, and I want it to head to the right. And so I'm going to have it on this side. Okay, what else do I need to know? I need to know the area that's in there. So it told me 61.4%. I'm going to change that to a decimal, and therefore it would be 0.614. Okay, so now I'm ready. I can go into StatCrunch, and I'm looking for the z-score. I want the z-score that's sitting right there on the number line. Okay, so I go to the normal calculator. I don't want to be between this time because I'm headed in a certain direction. So my mean is 0. My standard deviation is 1 because they didn't give me any more information. I know that I want to the right, so I know I need greater than or equal to, pointing to the right. And then I know that my area is 0.614. Once I enter all of that, the StatCrunch is going to give me the z-score that's on the number line down there. And so in this case, that z is going to be negative 0.29. Okay. We know that it's negative because we have 61%. That's more than 50. So that means that 50% was all taken care of on this side. I need to go just a little bit more over here to get up to the 61%. Okay, these are just more examples for you to try. It goes back to percentile, so I did want to show you this. The first one says the height that represents the 95th percentile. All right, hopefully I can erase that. Just a second. Let me try. Okay, good. All right, so that is really, let's start down here. So that's like the problems we did in the part 1, where we had P of 95. They did give me up above. So notice up above, I didn't read the whole question. That wasn't good. The mean height was 64.2 inches. The standard deviation is 2.6 inches. So when I go into the normal calculator in StatCrunch, I need to put those in. So I'm going to put the mean of 64.2 and the standard deviation of 2.67. Now, if you do these by hand using Help Me Solve This, they're going to make you change those and use a formula. So let's stick to StatCrunch and let StatCrunch do most of the work for us. All right, so now we know, because they didn't tell us anything other than that we're doing the 95th percentile, we're going to head to the left. We only head to the right if they give us indication. They either say that we want to head to the right, or if they say the top 95th percentile or the top 10% or something like that, then we would head to the right. But this one, we're going to head to the left, and then we're going to pop the 0.95 into here. At that point, StatCrunch is going to give you the score. So this score, if you, let's see, this is height. So with this 68.59, if a woman came in at that height, what would happen is she is taller than 95% of the other women. Okay, let's look at the other one. So the other one asks me to look what height represents the first quartile. So remember, with our quartiles, that's going to be 25%, 50%, and 75%. So I'm really finding, because it's the first quartile, I'm finding the 25th percentile. And so I'm going to do the same thing. I'm going to head to the left because it didn't tell me otherwise, and it said the first quartile. So I'm going to put in my mean, standard deviation, less than or equal to, and 25% in as a decimal. And at that point, you hit compute, and it's going to show that if a woman came in with a height of 62.4 inches, she would be at the 25th percentile. So she would be taller than 25% of the other ladies. Okay, last problem for this video. Let's see what they've got here. They gave me this graph right here. So they showed me that the mean is 3.4, standard deviation is 0.88. And the first question is, find the maximum score that can be in the bottom 15% of the scores. Okay, so bottom 15% means that we're going to do less than or equal to. 15% is going to go over here as a decimal. And then once we hit compute, it's going to give me the z-score. In this case, it was 2.49. Okay, so this is a little repetitive, but I just wanted you to see that the problems could be worded a little differently. The second one is find what two values does the middle 70% of the scores lie, between what two values, excuse me. So we're going to do the same thing. We're going to enter our mean. We're going to enter our standard deviation. We're going to enter our 0.7, which is our 70%, after we hit between. At that point, they're going to give us the two scores. Now notice they don't look symmetric like that other problem. That's because these are raw data scores. These are not standardized. When it's standardized with a mean of 0 and a standard deviation of 1, these would look symmetric with one being negative and one being positive. But since we're looking at the raw data, it's a little bit different. And so we would answer 2.49 for the bottom value and 4.31 for the top value. So I hope this helped you. Good luck with StatCrunch.